Alright, today we're going to extend our laws of logarithms. Just as a recap, here's some proofs of our exponent laws that we had. We had a product of two functions, we add the exponents. The quotient of two powers, same base, we subtract the exponents. Power to a power, of course, we multiply. Exponent of 0 gives us the answer of 1, depending on our base. Negative exponents, of course, meant fractions. And we always have this change of base that we now know as well. So what I'm going to do is I'm going to take a couple. I'm going to let the log of x base a equal to a value m. I'm going to let the log of y base a to be equal to a value n. These values are arbitrary, and we can go. And hopefully you can realize. So when we have our logarithmic versus our exponential form, right, and we can see that exponential form, x equals a to the m and y equals a to the n. Now what we're going to do is we're going to do a few things to this and see what happens. Right? So what I want to do is I'm going to take the product of these. So let's look at the product. So we would have, of course, x times y. But if I look at the other form, I would have, of course, a to the m times a to the n. Right? And, of course, my exponent laws tell me I can, of course, add those together, right? So that xy is equal to a to the m plus n. Right? And I think that's fairly straightforward, and we can see our product rules right above. Powers at the same base, add the exponents. All is good. Now, let's move that up a little bit because we want to do some other stuff to it. What happens now if I take the logarithm of both sides? So I'm going to take the log of base a of xy, and I'm going to take the log base a of my right side, which is, of course, a to the m plus n. Now, if you look at the right side here, I have a logarithm and a power, both base a. And of course, we know over the last few days, we know that those will undo each other or cancel each other out. And this is actually m plus n. So I have the log of xy base a equal to m plus n. Now, you might think this is a little silly, but what is m and n? Right? What was our original? What is m? Well, if we look back up to the top, and we look back when we first started, we let log base a of x be m. So my log base a of xy is m, which I knew from the original is log base a of x, and similarly n is the log base a of y. Now let's take a look at that. So the logarithm of the product xy base a is actually the addition of the logarithm of x and logarithm of y base a in both cases. And remember, so this is the law of logarithms for products. There it is there. This always is true. Now if we think about it, remember the logarithm is exponents, and what do we do with exponents? We add them, right? When we have powers of the same base. So this is the product law of logarithms, and which is kind of neat. Now the nice part is we can look at a quotient as well. And what will happen is if we look at the quotient, and we can go through the similar process, but our logarithm, change that pen, the logarithm of x divided by y, base a, if I have a logarithm of a quotient, it will be the logarithm of x base a minus the logarithm of y base a. So it will actually be the subtraction of those two. And remember, what do we do with exponents when we're dividing powers of the same base? We subtract the exponents. And herein lies the quotient law of logarithms. Okay, and those are two powerful statements, and it allows us to do a lot of stuff, because what it does, if you look at the right side, we have two logarithms. So long as they're the same base, we can actually bring them together as a single logarithm, which helps us in a lot of different cases. Okay, so let's try a few of those examples. So let's take a look. We're looking at right as a single logarithm. We don't want to solve these. And so what we're noticing, of course, is we have our bases here are both base 10. So we can bring this together as a logarithm base 10. And of course we're adding these two logarithms, so it becomes multiplication. So we have the logarithm of 20 times 3 base 10, or the log of 60, which is 20 times 3. And there's our answer, single logarithm. Second one, we're looking at both logarithms have base 3. We're adding. So we're going to take the logarithm. We're still going to have base of 3, but we're going to have 12 times 4 because of the addition, which means we have the logarithm of 48 base 3. And there's our single logarithm for this case. And so that means a lot, right? Because we can simplifying has just become that much easier. Let's look at a couple more. All right, so again, logarithm base 21. So we're going to keep that base of 21, and we'll have 4 divided by 17 as our value inside of our logarithm. And we can extend it to 3 terms, or even more. So the first one, of course, logarithm base 5, we're going to have 4 times 6, and we can actually do it all at the same time. We're going to divide by 3 because of the subtraction, since all were base 5. And of course, if I do a little bit of arithmetic there, I'm going to have 4 times 6 of 24 divided by 3, I do believe gives us 8. So this 3 logarithms actually simplifies to the logarithm of 8 base 5. Okay? Let's try. Ooh, what are we going to do with this one? Now this one's tricky, and it's not because of the binomials actually. The trickiness comes in actually because of these 2's out front. In all of our logarithms, in the power law of logarithms and the quotient law of logarithms, we can't have coefficients. So I need to get rid of them first. I can't combine if it has a coefficient something other than 1. So what I do actually is I'm going to move those coefficients up into the exponents. Because remember, of course, we can bring down our exponents. Well, we can also take them up. So we're going to have x minus 2 squared minus the logarithm of x plus 1 cubed base 4. And now that we have logarithms with 1's as our coefficients, now we can bring them together. Since it's division, it will be division because of the subtraction. So logarithm base 4 of a division, I'm going to have x minus 2 squared over x plus 1 cubed. And there's my single logarithm. Now it may not look as nice, but it is a single term, right? Versus multiple terms. And that a lot of times will allow us to cancel things and make things a lot easier. So be careful. Those coefficients have to become exponents before we can use the power law of logarithms or the quotient law of logarithms. Let's try a different one. Let's evaluate a few things. Now we're getting into some values. Now, of course, again here, watch yourself. That 3 that's up front has got to be moved up first. So we're going to do 8 to the log exponent base 8 of 5 cubed. Our power and our logarithm, of course, cancel each other out because of the base, so we're left with 5 cubed, which of course is 125, and we know that. So it works out quite nicely. Let's do the same thing again. Right, I've got a power of base 4. I got a logarithm base 4. I'm going to bring that negative exponent 9/25 to the exponent negative 1/2. So we got a lot of powers here, but our logarithm and our power cancel each other out. So we're left with 9/25 to the exponent negative 1/2. Of course, the 1/2 would take the square roots. The negative would flip it, so we're going to end up with square root of 5, or square root of 25, which is 5, over the square root of 9, which is 3. And there's our final answer. Part C, we have coefficients of 1, so that's good. So the logarithm of 75 divided by 3, base of 5, which of course is the logarithm of 5 of 25. And we recognize, of course, that 25 is 5 squared, which means, of course, our answer is 2, because our logarithm and our power cancel each other out. Okay, so be careful of the logarithms to make sure that you get rid of those coefficients and make them powers first. A couple more. Here we have the base of 2, so we're adding, so we're multiplying within our logarithm. Log base 2, I'm going to have 24 times 4/3. And of course, 3 goes into 24 8 times, and 8 times 4 is 32, so I have the log base 2 of 32, which of course we recognize as a power of 2. And it's 2 to the 5th, which means, of course, when I take my logarithm of that power, I end up with 5. Okay. Now another thing you can do, part E, there's a couple different ways we can do this. We can move our 1/2s up all the way, or what I notice, of course, is in that last term I also have a 1/2 as an exponent, which can come out front. So I could actually common factor it out first if you'd like, or you can bring it into the exponents. Our typical way would be to bring them up into the exponents, and we may not have recognized it at first, our other one. So we have the logarithm base 4 of 40 to the 1/2 plus the logarithm of 96 to the 1/2 base 4 minus the logarithm of 15 to the 1/2 base 4. So they're all bases of 4, so I can bring them together. Now, don't worry, you don't need your calculators. Right? We're going to have 40 to the 1/2 times 96 to the 1/2 divided by 15 to the 1/2. Right? As we add and subtract accordingly, bringing it into our power law and quotient law of logarithms. Now they're all to the exponent 1/2, which means, of course, if you think about that, I'm going to have 40 times 96 over 15, all raised to the 1/2. Now if we do that, of course, we can do some canceling. 5 goes into 15 3 times, goes into 40 8 times. 3 goes into itself once, and into 96 32 times, which means, of course, I have the logarithm base 4, and if I look through that, I get 8 times 32 to the 1/2. Oh, but I know that. 8 times 32, what's that value? Well, if we work it out, and I get 256 to the 1/2. Now, you might not be able to think of 256, but if you look at the last one, you actually know this answer. Because if you look at 8 and 32, well, that's really 4 times 2 and 16 times 2, right? So, and the 2's can go together, so you got 4 times 16. This power's a 4. Oh, hey, that's 16 times 16. Oh, cool. Which means the log base 4 of 16, because the square root of 256 is 16. It's off to the side here. Which means, of course, I make a little bit more room. I actually have the logarithm base 4 of 4 squared, which of course is 2. Cool. So we did a lot of work there, right? And just a little bit of thinking, and we didn't have to use our calculator, right? Which is really nice, and we can do that. Okay, so bringing it together, watch those powers. Make sure you bring out the coefficients, because you can't use the power law of logarithms or the quotient law of logarithms if you have a coefficient other than 1, or -1, that is. So be careful of that. Okay, so let's try a few. They're on page 384, sorry, and we'll answer any questions that you have tomorrow.